All right, if you're an Android developer, you have definitely heard the buzz around Jetpack Compose. I mean, it's everywhere. But what's really going on under the hood? Well, in the next few minutes, we're going to cut right through the noise and break down exactly what makes this modern UI toolkit tick from the ground up.
So here's our game plan. We're going to start with the massive paradigm shift that Compose brings to the table. Then we'll see how you can build entire UIs with just simple functions. After that, we'll get into side effects, dive into making your apps run smoothly, and wrap up by solving a really common testing headache.
Okay, first things first, the paradigm shift. You see, to really get Compose, you have to understand that it's not just a new library. It's a completely different way of thinking about building Android UIs.
So let's start with the big question. What is Jetpack Compose really, and why is it such a big deal for Android development? To put it simply, it's Google's answer to modern UI development. It's built 100% in Kotlin, which means you can finally say goodbye to all that clunky, hard-to-manage XML. Instead, you just define your entire UI right there, in the code you're already writing. And this right here, this is the core idea. Think of it like this. The old imperative way was like giving your app step-by-step driving directions. You'd say, find this view, now change its text, now make it visible. But with Compose's declarative style, you just show it a picture of the destination. You say, hey, for this state, the UI should look like this. Compose figures out the how. And that simple shift is an absolute game changer.
Okay, so if we're just describing our UI, how do we actually do that in code? Well, the answer is surprisingly simple, and it all comes down to functions.
Seriously, in the world of Compose, everything is a function. A button, it's a function. A text label, a function. An entire complex screen, you guessed it, it's just another function, all marked with this special @composable annotation. It makes your UI super modular and reusable from the get-go. Now, a UI that can't change is pretty boring, right? To make things dynamic, we introduce state. By using remember with mutable state of, you're basically telling Compose, hey, I want you to watch this value. And whenever that value changes, Compose automatically reruns, or as we call it, recomposes, any part of the UI that uses it. It's like magic.
And this whole process is incredibly efficient. Under the hood, Compose doesn't waste any time. For every single UI element, it follows a strict three-step process. It measures its children, then it decides its own size based on that, and finally, it places the children. It's a single, optimized pass through the UI tree. No wasted work.
So, building UIs that react to state, we got it. But what happens when you need to do something that isn't strictly UI related? You know, like kicking off a network request, logging something, or showing a snack bar message. How do you handle that stuff?
Well, that's what we call a side effect. And here's the tricky part. Remember how composable functions can be rerun over and over again? Because of that, you can't just launch a network request from inside one. You'd end up with a dozen requests firing off. So we need a safe, controlled way to run that kind of logic.
And for that, Compose gives us a perfect set of tools called effect handlers. Think of this table as your cheat sheet. Launched effect is your go-to for running something once when a screen first appears. Remember coroutine scope lets you safely launch background work from a user action, like a button click. And disposable effect is for anything that needs cleaning up when the user navigates away. Okay, now that we have the fundamentals down, let's level up and talk about performance. A declarative UI is incredibly powerful, but you gotta be careful. If you're not, it's actually pretty easy to make your app do way more work than it needs to, which can really slow things down.
And this quote from developer Yoon-Ho Lee just says it all. Recomposition is the heart of Compose, right? But unnecessary recomposition, that is the #1 enemy of performance. So our goal is really simple. Make sure the UI redraws only when it absolutely has to. And one of the biggest performance wins you can get is by delaying when you read a state value. Look at the example on the left. The parent reads the state, which forces the entire component to recompose. But on the right, we pass a little lambda function instead. The state is only read inside the specific child that actually needs it. This means only that tiny part of the UI recomposes. It's such a small change, but the performance impact is massive. But what about state that changes constantly, like, say, the user's scroll position? You can't recompose on every single pixel change. That would be a performance nightmare. For that, we have two amazing tools. You use derived state of when you only care about a calculated result, like whether a scroll to top button should be visible. And use snapshot flow to turn that state into a Kotlin flow, which lets you do more complex things, like triggering an analytics event once the user scrolls past a certain point.
This all ties back to those rendering phases we talked about earlier. Here's a pro tip. If you can wait to read a state value until the later layout or draw phases, for things like changing an element's position or opacity, you can often skip the most expensive part, the composition phase, completely. It's an advanced technique, but it's incredibly powerful. All right, for our last section, let's tackle a really practical problem that trips up a lot of developers who are new to Compose. How in the world do you write automated UI tests? This Reddit post just captures the issue perfectly. Older testing frameworks, like UI Automator, rely on finding those old XML resource IDs to see what's on the screen. But in Compose, those don't exist. The official replacement is something called a test tag, but those old tools can't see it by default. So, are you just stuck? Nope. And the solution is actually so simple and elegant, you're gonna love it. You see, Compose has this powerful system called semantics that describes your UI for accessibility tools and, you guessed it, testers. With this one single line of code, you can tell Compose to expose your test tags as if they were old-school resource IDs. Just like that, your entire UI becomes compatible with UI Automator. Problem solved. And that's our quick tour of Jetpack Compose, all the way from the core declarative mindset to advanced performance and testing. The main thing to take away is this. By understanding these core mechanics, you're not just learning a new library. You're unlocking a way faster, more powerful, and frankly, more fun way to build Android apps. So the only question left is, which part of the Compose paradigm are you going to focus on mastering next? Thanks for watching.